you should erase it. He doesn't like it.
Professor.
Yeah. Yes. Point 0, he doesn't like it. And then both should be aligned. And one more thing, there should be one more space. And this one should be on the middle. But I think in this case we just removed it and just like maybe this is better. I like this one.
Okay.
And here should be one more space. And you can see this 0 useless. This 0 is useless, right? So go to here, display, custom, erase it, apply, and you can see.
Okay.
And this one should be 3 also 3 this one should be 4. Yeah, good. And these 2 should be 32. This one 30. So also 30. Inside about 22 to 26, everything is okay. So make it on here. Yeah.
And what about this?
This one? And this one also. So no bird is okay. It doesn't matter. You can board it and it doesn't matter. And yeah, everything is good now. 0.2, 8, 6. Yeah, it's good. And that's all. Yeah.
Now we want to find the mobility of this.
Yeah. Why is because of boards. But if you want to do both, just make it 30. Is also okay. Yeah, that's good. Oh, I think it's too big because you did boards. Maybe just don't board. It's better. Ah, I know why. Size is 49, right? Should be 32. That's why. And now you can make it 30. Yeah, good. Now everything's good. Let's see. Yeah, it looks good, right? And now you can calculate the mobility. In An's case, he did this one. It's also good. Or yeah, everything's okay. It doesn't matter.
Okay.
You can just make your own method. Doesn't like it. And first, if you wanna see the mobility, you should check the data. Now you don't have data on here, so I will just copy from here. You can differentiate on here directly, but if we do, it will be changed on here too. So I will not change on here.
Okay, so
Yeah,
always to open new sheet.
Yeah, new seats. So just close it, and we already copied it, so we can just. Oh my god! It looks good. So you're MOT2, right?
Yes.
Yeah, it looks good. I think mobility is not that much high, but looks. Yeah, now it's copied, right? So just close it. It doesn't matter for this. And we can. Oh, you just did on one axis, right? But in just my case, I just put everything.
It gives space between every.
Yeah, for all gate positions on here. Then this is extra axis, right? Can you get it? And then plot it. Actually, it doesn't matter. You can do on use also. And then analyze, differentiate. You can set up which one first. So you can see B, D, F, F, H, J, right?
Okay.
B is the 0.2, 0.4, 6, 8, 1, right? So I will do from B, right? And plot derivate curve. I think you can do everything. Is it? Okay, from the B. Differentiate now. On to T. Okay. Apple. H, J. Now I did everything, but it's not coming on here because I didn't check plot the wake curve. But it will come on the data sheet.
Okay.
B, D, F,
H,
H, J, right? So we can just plot it everything together at once. Now you can see, right? So you can set up one here, but I think in just my case I don't need to do everything, so I just pick up one. Maybe I will use just one bolt and then plot it. So now you can see, right? So maybe set up this part. There's the electromobility. It's Y. Copy text. And go to here. And Control V. And then you can see this Y value, right? This Y value is electron transconductance. And then here, this value is the text. It's small, right? Yeah. Then put it inside here. These lines will be different, right?
Yes.
And now we did how much drain voltage?
1.
1, right? And then put it inside. And we don't know this one. Maybe
Width is 4.
Huh?
4.
What is it?
Width is 4. This is 4 and length is 3.
For micrometer?
Yes.
I think you should do it correctly. I mean
it was 3.09.
yeah, something like
Yes,
it.
3.09.
So maybe do it later. More like
careful.
yeah, careful. And now it is just 1. And whole mobility is about 16. Yeah.
Negative sign does not matter.
Yeah, it doesn't matter.
So if we are writing this in paper, we don't need to write negative sign.
Yeah.
We just need to write 16.
Yeah. But in just this case, I will tell you. Maybe it's going down, so I just pick up this point. But in this case, really difficult to pick up one point because it's not saturated. Actually, it should be saturated on some time and then go down a little, and then we can set up the peak point, but we cannot see the peak point on here, right? So in this case, I want to recommend you more gate voltage. If you don't want to do, you just can pick up one point. But in this case, we cannot say that this is real peak or not. This can be real peak, or this can be some noise also. So maybe sometimes it's coming down and it's noise or something like it. In this case, if it's noise, we should pick up this point. In this case, you can see there's one noise. This is not the peak point. It's on red line. This is just noise. So real line will be on maybe here, right?
This is for whole. This is peak point.
Whole. Yeah. But in this case, actually, I just pick up this point. Then I also think this is the mobility because I already see that it's coming up on here. So it's suddenly up, so I can believe it. But more
accurate, we should go for more gate voltage.
Yeah.
So always need to take here extreme point and here peak
Yeah,
point.
peak point. Yeah.
The electron mobility, and it always whole mobility in downsize.
Yeah, that's all.
So this is the process to find out the mobility and then put in this sheet. So always all parameters are constant. Just need to carefully analyze the length and width and this value.
Drain voltage also.
Or just drain voltage need to change.
And then if you want to use the 90 nanometer thickness,
then
you
you
just
need to
change it.
change.
Yeah. That's all.
Okay, and the second question is, if we go to the graph, IDVG graph,
this one?
so this is threshold voltage.
Yeah.
So it means that as we increase the gate voltage, the threshold voltage is also decreasing because it suddenly
Yeah. Actually,
on.
Actually, you should check much more carefully on the threshold voltage, there's one way to calculate it. Just online. Maybe getting up. So about this part, you can say that this is threshold voltage. This also is now is changing a lot. The slope is changing a lot, so you cannot. Here is changing. One here also is changing a lot, right? Huh?
Today there is no lecture.
Yeah, no lecture. Still changing, right? So in this case, we cannot see exactly the point of threshold, so we can just maybe see on this part. I think this is enough. Maybe. Or this point. Actually, it's really difficult to pick up the threshold voltage on here. Maybe on here.
Is this because of measurement problem?
Yeah, it's not measurement actually. Sometimes it looks like this. It's still going up. So if it's saturated, I mean the slope should be saturated, and then we can know the threshold voltage exactly.
So if you want to find this value,
Yeah.
then how to identify it?
Fine. Just this one.
So on any axis, y-axis,
Yeah.
we need to find the value. We need to pick.
Yeah, on here.
We need to pick this
Then
and click on that, so it will give us the value.
this x.
And this is what is the function of this
This one. This one is the point of our
selection?
selection graph.
Oh,
Yeah, that's all.
thank
So
you, Jimmy.
actually, in threshold voltage, I think you should study more. I don't know too. There's some way to calculate the threshold voltage, but we cannot exactly say this is threshold voltage. So there's no paper about 2D materials. I think you never seen they only focusing on the threshold voltage. It's because it's difficult.
It's constantly changing, so okay. Thank you, Jimmy. Thank you.
Yeah, that's all. Then maybe you can just change some like format like this. So also.
Yes, I will change, and this should be VG, right?
Yeah.
Should I write?
Oh
VG?
yeah. Oh, it's my mistake. You should put it inside. Yeah. The other thing is really good. I think. Oh, you calculate really well and you put it really good. But I wanna recommend you more.
Yes, 3, always 3. This should always be 4. This should be 30, 28 something, and this should be 32. Come in the close window.
And I wanna recommend you put the log scale together. That is better. One more graph.
One more log.
Yeah.
To show it completely
Uh,
behavior.
I wanna recommend you just
So like log scale always give us the exact behavior.
sure.
Like from here, if this graph is n here,
In this
So-
case,
maybe we can say, oh, this is p type, but in log it will tell us more in detail.
in this case, I think we can know like dominantly of n type, right?
From
Yeah,
this
yeah.
behavior.
But sometimes we don't know, right? So in this case, I wanna recommend this is depending on drain voltage, so just leave it and you can just pick up one gate voltage, maybe I think Purpose doesn't like 1 volt, so let's do it
Zero.
definitely 2. Yeah, but I just copied 1 volt, so I will just show you on here. So we wanna put 2 y-axis, so put one more together. But this is for log scale. So in log scale, it should be everything absolute value. So absolute C, and then plot it. Not this one. Plot with here double y, because we wanna do with 1 x-axis and 2 y. You can see here, right? One is linear scale, the other is you wanna do log scale. So click it, scale, log, and rescale it, right?
Rescale from where you did?
Rescale.
Okay.
Now it's much more comprehensive. Now you can see what is this, linear scale and log scale. Oh, it's really good. It looks perfect amplifier, right? And now it shows the so change it to it. Alright, it's good. Then you can just see ID same. Maybe here let's do it nanoampere. And then change it to science peak, because Professor loves science peak. And we did nanoampere, so here you can see here's nanoampere, right? Here maybe do it, I copy here, it's better, and it's what I said. Same. This my copy, right? This is gate voltage. Now it's much more good, better, right? Then you can just mention that here. PD, right? There is 1 volt. I done my box. And T 300. And maybe on the PPT you can just do it. You can use this one. Maybe you can just use on here, and some arrow bar on here, and then low scale, and this one on here, and different color with LEDs. Yeah, maybe. Now we cannot change on here, but it's LED on here, and then it's much better.
So what is the use of this thing? Like what it indicates?
This is linear scale, right? So this one. This is low scale, so
So I should have arrowhead.
yeah, arrow on here.
Okay.
Yeah,
So
that's
one
all.
thing more, if we go to PPT, here is some ripples are there. You can see this.
It doesn't matter.
Even for paper it doesn't.
Yeah, it doesn't matter. Yeah, the two.
Thank you, Chief. Thank you so much. So I think 25 minutes
Yeah.
it is okay for today.
Yeah, actually, what I tell you about everything, already Anne knows. So maybe you can ask to Anne also.
Okay.
Yeah.
Thank you.
Yeah.